Hey guys, this is homework 2, graphing quadratic equations. And if you just look at what the expectation is, you're graphing the equation using a table of values. And then on the left-hand side, we have some characteristics that we're going to define. Write small because there is some work to be done. That will be helpful if you keep it small or even use an additional piece of paper. So at the top here, something that is very important to keep in mind is your axis of symmetry formula. And I am, let's see, I'm going to scroll down because I'm going to write it down again, maybe like in color. At this point, what about pink? So hopefully if you're watching this, you're thinking, ooh, gosh, what is that formula for the axis of symmetry? Well, we could, in fact, just write it right down here. The axis of symmetry, just to remind you, is x equals negative b over 2a. Then I'm going to simply use the standard form. Remember, this is your a, this is your b, that's your c. I'm just going to simply plug in some values now to try to solve for x. So over here, I'm going to solve, I'm going to put this into my formula. X, let me zoom in a little bit more, x equals, well, if b is 10, well then negative b must be negative 10. I'm getting it from right here. And then I'm dividing it by 2 times my a value, which is 1. Now I end up with negative 5 over 2. That was pretty silly. I can see I'm going too fast. I'm going to end up with negative 10 over 2, which ultimately gives me to negative 5. So x equals negative 5. So that's my x side of the equation. So I can put that in, and what that means is x equals negative 5, and that is the axis of symmetry. So x equals negative 5. Now to find my vertex, remember I need a coordinate pair to be my vertex. I have my x here. I'm going to plug my x back in to this equation up here to get a y. So here we go. I'm going to write y equals negative 5, because that's my x over here, squared, plus 10 times negative 5 right here, plus 26. I'm going to keep writing y equals 25, because negative 5 squared, minus 50 plus 26. Y equals, well, I know 25 and 26 combined are 51 minus 50. So y equals 1. Okay. So again, what that means is, and then I think in the past, I think I did something like this. Like once you find, when we were reviewing like systems of equations and plugging in and substituting, that once you got your x and y values, it's helpful to actually put a circle around them and then plug them in where you need to. So our vertex is negative 5, 1. Now our tips were that whatever the vertex was, we should put in the middle line of our table. So let's go ahead and plug that in. I have a negative 5, 1. Okay? And again, that is a very important point that we'll graph in just a moment. So now I'm going to decrease over here. These are going to get a little bit smaller. And then I'm going to go a little bit higher here. So whatever you're going to base this golden 5, you think about based on what the vertex is. And then these are going up, these are going down. Okay. If I now just substitute negative 4 into this entire equation, I'm going to end up with 2. I'm not going to model every step of this, but again, where I got this was negative 4. I went back to my original equation, and I plugged it in just like I did for negative 5. So negative 4 squared, so I'm going to get 16 plus 40 plus 26. I'm going to end up with 2. If you don't try it out, if you don't end up with 2, I would try it again. If I plug negative 3 into my original equation, I'm going to get my y value after I plug it in as 5. Now back here, if I need to plug in my negative 6, I'm going to get 2, and then you could probably determine or even predict that my negative 7x will result in a y output of 5. I have my axis of symmetry of my vertex. Can I in fact graph this? I can. As far as the domain and range, remember the domain for really all of these types of graphs and functions are all real numbers that I can put into my machine. The range, I'm going to come back to that in just a minute. So let's go, I'm going to move it over here to my graph. And let's start, I always start with my vertex because that is the most important point on here. And by the way, is this, let's go back to the equation for a minute, right here. Is A positive? It is positive, it's positive 1. So I get to draw a happy face, which means my parabola, my smiley parabola is going to open up. So let's go over here. 1, 2, 3, 4, 5. I'm going to go to the left 5 on my x-axis, and I'm going to go up 1. That, my friends, is the vertex. Now I'm going to do, let's just do -4. We're going to go to -4 and up 2, -3 and up to 5. 1, 2, 3, 4, 5. So it's going to look something like that. Now, if this is the axis of symmetry, right here, well, that means that I should have the same points over here. Let's just see. Oh, see? It's better to actually be a little more scientific about it. Let's just make sure that matches up. So if I go back 1, 2, 3, 4, 5, 6, 7, and up 5, 1, 2, 3, 4, 5, I've just plotted this. And now I have a good 5 points where I can plot. And there is my parabola that I just sketched out. My vertex is right here. It's opening up, so this is the minimum. And now I can look back to that question about what is my range. Well, the range is really what are all the values that y could be? Well, y can it be 0? No, it doesn't touch 0. Can it be 1? Sure, and it can be anything above 1. So y is greater than or equal to 1. Okay. Now let's move on to number 2. Actually, let's go to number 3. Since you're just doing the odds, I might as well do the odds with you. So number 3. Guess what I'm going to have you write again? You don't need to, but I am going to keep reminding you of that. That's important. And what's my A? And I would strongly encourage you to even list out, like A, what's your A value here? Well, your A is 1. What's your B value here? -2. Okay. So let's plug it into our formula. So x equals, I should have a negative, be careful of this one, -2. And that is all going to be 2 times your A, which is 1. It's kind of funny. And I'm going to end up with negative times -2 is just, well, 2 divided by 2, which is 1. Okay. So I have my axis of symmetry, which is x equals 1. And I know the vertex is going to start with 1, because I get to just plug it in. And now, I am going to use 1 to plug into my original equation. So I'm going to rewrite it. X squared, which is really 1 squared, minus 2 times 1. Y equals, well, 1 squared is just 1, and then -2 times 1 is -2. And now I have y equals -1. So there I have just found my y, my value for y. So my vertex is at 1, -1. My domain, you can keep writing this forever until the cows come home, is all real numbers. The range, we won't get there yet, but hopefully maybe you're making a connection to this y value right here. Anyway, if I go back here, A is positive. So I'm going to be happy about that, right? Sweet. Okay, let's start plugging in. So my vertex I'm going to start with, I'm going to put on my third row. I have 1, -1. going to go up 2, 3, 0, negative 1, and now I'm going to start plugging in. Well, if I plug 2 here, 2 squared minus 2 times x, well, I'm going to end up with 0 because 4 minus 4 is 0. If I put 3 into my machine, 3 squared is 9, minus 6 is 3. If I put 0 in my machine, well, everything becomes 0. It wipes everything out. Put 1 into my machine, and I get 3 out. Okay, so that's my table of values. And let's go ahead and plot it. I'm going to take that now and go to my happy plot, my happy little tree plot. And let's start with the vertex. So I'm going to go over 1. And then if I have a negative 1, so I go over 1, and then I go down 1. So this is your vertex. Let's go to 2, 0. So if I go 2, 0, it's here. Sometimes it's helpful to even, if you do this right side, you can do the left side, and it's easier to see that symmetry. Because this one should be 0, 0, because we're at the origin here. Now let's do 3, 3. So 1, 2, 3, 1, 2, 3. And then I should have something similar over here, which is I go back 1 and up 3. 1, 2, 3, and it should be symmetric. And then I'm going to go ahead and connect my beautiful parabola. And remember, my axis of symmetry is 1, which makes sense because the x is on 1. That splits it in half. So now I can better see my range. So my range of data is that it can touch negative 1, and it has to be above negative 1. So it can touch and be above, which if I translate into math speak would be y is greater than or equal to negative 1. Okay. Now I will go to the back side. On page 8, let's do 5 together. Or let me model it, I guess. And you know what I'm going to write? I'm going to write x equals negative b over 2a. Again, the more you write it, the more you will memorize it. And that is a really good one to memorize. Okay. Over here, I'm going to write my values. So a is what? Looks like 3. B is what? Negative 5. Or is it? This is tricky. Well, this doesn't have a variable in it. Isn't this a constant? Actually, that is C. So you have to be careful of that. Do we have a B value? Meaning, do we have like just a linear x, like 3x? We don't. So that means that it is what? It's 0. B is actually 0. We don't really have one. So let's go ahead and plug this in. So I have x equals, well, and from the top we have a negative b value, which is 0. I think I already know where this is going. On the bottom, just let's do it anyway. I have 2 times our leading coefficient, which is 3. And then if I multiply that out, it doesn't really matter because 0 on top is going to wipe everything out, and I end up with 0. So x is 0. Now I get to plug 0 in to get my y. So y equals 3 times, well, 0 squared minus 5. Maybe you'll see where this is going. Y equals, well, anything attached to my 0 here, if I'm multiplying it, it just wipes everything out. So that becomes 0. And then I'm going to subtract 5 from 0. So I get to be in negative territory, negative 5. So my vertex is going to be my x value, which is 0, and then my y value, which is negative 5. My domain is that really fancy R. My range, well, can you use your range here? Can you figure it out? Hopefully you can. I won't show you yet, but I hope that you can do it. I'm going to go ahead and plot my vertex. And then let's go ahead and get some more values in here. So I'm going to go up each integer, and then I'm going to go down. If I plug 1 in, I'm going to end up with a negative 2 out. If I plug 2 in, I'm going to get 7. And if you get something different, I urge you to work it out. -1, if I plug in, I'm going to end up with -2. If I plug in -2, I'm going to get 7. Okay, let's go ahead and plot them. So, oh, back here, A is positive, so I get to smile about that. Makes me very happy. So happy. I have 0, and then I'm going to go down 5. 1, 2, 3, 4, 5. That is my vertex, right there. Now I'm going to go over 1 and then down 2. 1, 2. I'm going to go over 2. I'm going to go up 7. Whoa. 1, 2, 3, 4, 5, 6, 7. Ooh, that's big. Look at that. That's kind of a stretched out parabola if I've ever seen one. Let's see. I'm going to go back -1, and I'm going to go down to 2. Back 2, and I'm going to go up 7. So I should be right up here. And then I get to, oh, that's kind of a fun one. Okay, so here's my vertex. Again, this is a minimum point. If I look at my graph, I can also tell the range. How many y values can I have? Can I go below this, -5? I can't, but it will include it because it's touching it. It's not like the asymptote here, people. So our answer to the range is y is greater than or equal to -5. Boom, done. Going to 7 now. Okay, oh, this looks familiar at least. Oh, I only gave you that much. I may have to do one more. Let's go to 7 though first. So write your formula. Write your A. What's your A here? Your A should be, what do you see? Oh, this is negative. So I'm actually going to go ahead and draw that for myself. -1, right up here. And your B, well, again, do we have a B? Do we have just a linear term? We don't, because remember, this is the constant, and this is the A, or the quadratic. We don't have a B, so it's 0. Let's plug it in. X equals -0. I already know it's going to happen, but let's continue. And then I have 2 times -1, so X equals 0. I like when that happens because it's actually just sitting on the X, on the Y-axis rather, is the symmetry line. Your vertex, I'm going to start with model 0, and then over here I'm going to go plug it in. So I have Y equals, well, I've got a lot of zeros here. If I have an X is 0, it wipes everything out. So basically it becomes 0 plus 1 from the constant. Y equals 1. Okay, my domain is at per dr. And let's go. I'm not going to tell you about the range yet because we're actually going to map this out. So let's go ahead and graph or plot our table. Get our table done. So vertex is, we have 0, 1. If I plug 1 in, I have anything that 1, if it's squared, it's going to wipe away the negative. So I got 1 plus 1. And what is that going to be? Plus, and that's going to end up with 0. I'm going to have 2. I'm going to have, I put 2 in there, 2 down 4. I'm going to get -3. And then this whole term, by the way, becomes negative. Which I don't know if you notice that, but I may have to model that for a sec. I'm going a little too fast. So if my x is -1, let's go look at that. If I have -1 squared, well, it's still going to be 1 that I'm inputting, but then I have a negative sign in front of it, so it's -1 plus 1 is 0. If I put -2 in here, -2 squared is 4, but now I have a negative sign, so it's -4 plus 1 is -3. So let's go back here for a minute, because I think I glossed over that. If I put 1 into my machine, I have 1 squared, but I have to make it negative because there's a negative coefficient. So that means it's -1 plus 1, which is 0. And then 2 here, if I have 2 squared, which is 4, and I make it -4 plus 1, then I end up with -3. Okay. Now I'm going to go and start plotting this beautiful graph, starting with our vertex. So I have 0. And where am I going to go? I'm going to go up 1. Then I have 1, 0. 2, down 3. Now let's go to the other side. So I have negative 1, 0. And then I'm going to go back 2 and down 3. 1, 2, 3. Now, oh, I have a cute little one. It's very cute. It's kind of tight. Remember the other one was really long. Here is my vertex. Oh, interesting. Because remember, I'm very sad because it's negative. What's my range, though? So I have this high point. My vertex is the highest point, which is here at 0, 1. Well, what is my range then? Can it be 1? Yes, but it cannot go over 1. So this is going to look a little bit different. So now I'm going to have y. Is it going to be greater than? Well, no, it can't because it's not going up. Now it's going down. It can be less than or equal to 1. So if you get a negative a here, your range, you're going to flip that sign if you flip it because everything's going to be below that. Okay, let's do one more. Let's just do 6, just to get one more practice problem in. And this looks like it could be tricky. So I'll do it one more time. It's negative b over 2a. My a is negative 2. I have a b this time, it's 12. Okay, now let's plug and play, people. I have x equals, well, what's negative b? Negative b is negative 12 over 2 times negative 2. That equals negative 12 on top of negative 4. And I should end up with 3. So I have now x equals 3. I can even plug that into my first part of my vertex. Now I can plug it in. Y equals, well, negative 2 times 3 squared plus 12 times 3 minus 15. Y equals 9 times negative 2 is negative 18. 12 times 3 is 36 minus 15. And when I combine these all together, looks like I'm going to get 3. Okay. Plug. Here's my vertex. I can put my R in if I want, and then I'm going to go up, and I'm going to go down, and I'm going to plug this in. If I plug it in, I'm going to get 1 on the outside. I'm going to get negative 5. Oh, it's going to be a pattern here, and negative 5 here. And now I get to, oh, first of all, what's the nature of this? This is a frowny face. So the parabola is going to go face down. Now let's plot it. I have 3, 1, 2, 3. So that's where I should start. I've got 4 and up 1. I've got 5 and 1, 2, 3, 4, 5. I have 2 and up 1. Makes sense. And then I have 1 and down 5. Okay. Vertex is here. My range is going to be that y is less than or equal to what? Well, 3, because I'm using it from here. Okay, best of luck. You can do it.